Welcome everyone to this virtual reality CAD live demonstration from SkyReal and Riot Digital. Here, we're going to show you how virtual reality can dramatically reduce design and development time on energy sector installation and maintenance projects. We're also going to show how this approach facilitates much broader stakeholder involvement throughout that process, allowing informed observation and vital design input from end users, planners, estimators, installers, and of course, clients. We will show how the system can be used to perfect designs before installation, reducing and quantifying time and monetary investment, generating higher engagement from previously disconnected stakeholders, and bypassing the barriers of location and travel, which have frankly always been an impediment to these type of projects and is now more of a barrier than ever. My name is David Syme, and I'll be presenting this system to you today. I'm the co-founder and technical director of Riiot Digital. I'm a practical virtual reality specialist with a background in energy transition projects and industrial training. I work with Google and the Chartered Institute of Marketing and Modern Apprenticeships, and I've been active in digital communications field for about 22 years. Today, I will be ably assisted by Nicholas Moncel and Hugo Falgron. Nicholas Moncel is in charge of the customer support and software quality at SkyReal. Nicholas has a mechanical engineering background and will be performing a live demonstration of our multi-user virtual reality CAD development tool today. Hugo is the CEO and founder of SkyReal. He is a specialist in engineering, R&T, and innovation, stemming from his background in the aerospace sector, which is what led him to create the SkyReal system in the first place. Hugo and the SkyReal team will be answering your questions in the chat just over to the right there, and that will be passing them to me wherever they're appropriate as we go on. But I'd like you to keep speaking in the chat and keep speaking in the questions section as we go, and then we will come back to these and answer them live. Now, we do have a lot to show you today, so in order to give you as much information as possible, we'll be keeping audio questions off till the end. However, as I mentioned, Hugo will be available in the chat throughout this session to answer any ongoing questions you might have. Rest assured, your identities and company names will be kept anonymous. It's first name only on there, so do feel free to ask anything you want to know throughout. I'll come back to the more complex questions at the end of the session. Also, this session will be recorded and made available to you afterwards, so you can review it or share it with your colleagues. We'll also compile all the questions and answers that arise during and after this session and share these with you too as a document, so there's no need for taking any frantic notes as we get through, okay? So today, we're going to take you through the functionality of this system, showing you how SkyReal works, how it can be applied to tasks like design reviews, realizing models in virtual reality straight from CAD models, and how it can be used to actually develop and design installations. We'll be building a pipework installation in VR in a matter of minutes before exporting it back to CAD. We're also going to show how it can be used for worker health and safety purposes by planning installation ergonomics against life-size virtual workers, which we call mannequins. And finally, we'll be taking any questions that you might have throughout the session. So let's get started. We spent a lot of time ascertaining what the greatest barrier is to getting people to engage with digital design tools. And the answer has been overwhelmingly over the years that the systems are too complex to use. We all have busy work lives and schedules, so it's unrealistic to expect engineers, end users, estimators, and owners to learn how to use AutoCAD, Revit, or SolidWorks just to keep tabs on ongoing design processes. Therefore, we've created the simplest yet most flexible user interface we could so that new users from any discipline can instinctively get to grips with it. Any user just has to put on a virtual reality headset, which can, and then they'll be projected into a real one-to-one scale virtual reality world where they can see, speak with, and collaborate with colleagues, meaning that different experts can discuss the process clearly, live, and in context. With just a click of a trigger, the interface you see on the right there will appear, and by clicking on the appropriate icon, the user can immediately start interacting with their environment. So rather than just me describing it, Nicholas is going to take us into a live demonstration. There we go. So by clicking on VR, Nicholas enters the world directly in his headset. And then he can move around the platform, starting by flying anywhere that he wants to go. Once he reaches the area, he can also teleport anywhere he points to with his pointer. Now, the advantage to this is that this eliminates the motion sickness that some people still experience, although a lot fewer people experience motion sickness in modern virtual reality headsets than ever. But if you want to completely eliminate any chance of that, instead of moving around by walking around, you can just click where you want to go and appear there. And that completely eliminates motion sickness, meaning that anyone can use it. You don't have to worry about it. However, he can also walk around like he would in the real world. So if you're more comfortable with it, or you want to move around as you would. Now that's so realistic that he actually, if he comes up against objects, he wouldn't be able to just walk through them. He would come up against them and be stopped. If he wants to get under objects, he literally has to crouch or crawl on the ground to get under them. This is what we call 6th degree of freedom. The modern virtual reality headsets actually know where you are in space so that you can move around naturally. Now that can be extremely useful when training or familiarizing yourself with the real world constraints that you will come up against when you actually are in that scenario. So very, very good for training. Finally, there's a mini map where you can position yourself where you see your collaborators or where you want to go so that you can join them and move directly into this space. So now we've arrived at our point of interest, which is on the first floor. Using this collaborative mode, we can see and talk to each other, which is really useful for guiding stakeholders, particularly stakeholders who might not be so familiar with the actual physical environment. It allows us to work together, talk together, and even train together. Now, what we're going to do is look at some of the ways that we can interact with this world. But first, we're going to stop for your initial questions, okay? Okay, so any questions that you might have, I want you to put them in the question tab over at the right, okay? So anything that I don't get to now, or anything that Hugo doesn't get a chance to answer now, we'll try to come back to at the end of the session. Now remember, anything that we don't get throughout this entire session, we will be collating this and sending out to you later on, so don't worry, okay? Let's have a look at the questions that are coming in already. I see that there are some. Can you overlap the AR, augmented reality, CAD, computer-aided design, and BIM, building information management, files using object recognition? The reason is to retrofit existing factories and then use a HoloLens. You can get rid of the avatars but work in real life. That's a very good question. And there are tools that can do that. And as Hugo suggests, we can actually do that. That's not a problem. It's amazing the capabilities of this. Now, I do encourage all of you to ask any questions that come into your head. If there's anything that you're not sure about, there's a very good chance that there's other people in the seminar who also aren't sure about it. So you're not just helping yourself, you're helping them. And it also helps inform us as to how to make these presentations more informative in the future. So please keep coming with the questions as we go, okay? While I'm waiting for that, I'm just going to have a quick look at the chat. And let's see who we've got in here now. Edward Murphy, hello. Peter Waggett, hi Peter. Fuad and Atanas, hello both. Okay, and again, while we're waiting for more questions, I'm going to do a quick poll. Now you'll notice just to the right of the questions tab, there's a polls tab. So I want you to go into that and I'm going to make a poll live. Just a second. Now the poll I'm going to bring up is going to ask what industry you're a part of, okay? So I'm just going to bring that up because that's going to be really useful for us to get an idea. There we go. You should see that appearing now. That's going to be really useful for us to get an idea where you guys are coming from and what kind of requirements you might have. So the poll's asking, let's just have a look at the chat and make sure that everybody's able to see that. Yep. Okay, that's good. Right, if you can go through here, I've asked whether you're part of oil and gas, renewables, construction, mining, education, engineering, aerospace, or if it's none of the above, and I say that we do have a none of the above, if you can just go into the chat and let us know what industry you're from that it isn't on the poll. We've got 3 people that are none of the above, so we'd love to know what background you're from. I noticed that I forgot to put agriculture in there, so if that's one of them, then please put that in. At the moment, oil and gas is in the lead at 25%, then renewables at 15%, which is as expected. There's education at 20%, and then engineering. Very good. Okay, you keep that coming in, and I'll keep progressing through this. I do have another question that came in on the chat, so I'll just ask that. I'll just answer that first. Can the system identify cracks or problems in upper parts of the rig as drone can identify? Now, this system takes in CAD models. So basically, anything that's in the CAD model, it can identify. If it's a CAD model which has been created from BIM or has been constructed in order to actually monitor things like damage or degradation, then yes, but it can only see what's being put in. So if it's in the CAD model, yes. If it's not in the CAD model, then no. Now let's see. We've got some of the other ones that have come in here in terms of industries that you guys are part of. We've got medical from Andres Gonzalez. Hi, Andres. And patient care, primary care. Ah, brilliant. Okay. Then we've got Roger says supporting companies to improve manufacturing capability. Very good. Yes, this can be used very, very strongly in manufacturing. And Eddie, hi Eddie, as Edward Murphy said, procurement, all sections, mainly industrial manufacturing. Good stuff. So it's important to, I'll just get this video going. It's important to remember that this isn't just a visualization tool. It's a real engineering design tool. So as well as being able to import accurate models from CAD files, we can also accurately manipulate them and then export them again in CAD format. Our next live demo session is going to show how this can be used for tasks like creating design reviews, creating tickets for other people, other specialists, notifying them of areas of an issue or areas of damage or areas that they have to address, and then making tickets for them, which are actually contextually in situ so that they can see not only what the problem is, but where the problem is. Also making design changes. So having seen a ticket, we're going to show how you can then alter the model to adjust it according to what the issue was from the design review. Next, we're going to show how we can design things like piping and cable work, and some of the stuff that you see in the little video to the right there. And also configuration design management, making sure that things are in the right place, fitting together, and making sure that people can get access to them properly. So I'm just going to go back to you, Nicholas. Here we have 2 people working in the same scene collaboratively. Do you see the other person there? They're represented as a kind of a robot. Hello. Now, together, you can have multiple people in here, but together we've identified an issue. And these 2 colleagues are highlighting this for maintenance and design engineers by adding a ticket to describe that issue in detail. You see how we're highlighting it there? And Baptiste is just about to add a note. Now you see that these 2 pipes are too close to each other, which could create issues of heat leaching or overheating. And this means that by doing this, by highlighting this and putting the ticket there, the maintenance engineer and design engineer can then come back and decide how to remedy this. Now, Nicholas are going to be, and Baptiste are going to be the design engineer, and they're actually going to go and have a look at how they would then change that. So in the VR scene, they can actually design a new layout, as we're seeing here, live with a really simple pipe designing tool. And we have a similar design tool for cabling design and other ones that we'll show you shortly. So as we can see, they're showing different pathways that these pipes can take so that they're not as close to each other as they previously were. This is the kind of process that can be done in CAD but can be a bit time consuming. And having the end users observe it can be a process of design and then passing the design back to the users or stakeholders, getting their approval or modification, then passing it back to the CAD designer. In this scenario, it can all be done live and at once with everybody commenting on it at once, which can dramatically reduce the amount of iterations and the amount of time it takes to get everybody's approval and agreement on what is and what isn't appropriate. I'll just wait for Nicholas to finish this off, and then we'll show you what else we can use this for. There we go. Now that didn't take long. So that's the pipework redesign draft. Well done, Baptiste, for approval. So we can see what happened there, but we can actually quickly show before and after comparisons as well by switching them off and on. What we can also do is photograph the work in virtual reality, which can then be exported and viewed outside of VR for quick comparisons and for quick stakeholder approvals for people who aren't there live or don't have access to the system itself. There's a before and after. And you see the difference? And you see how clear and easy that is to see? Now, once these have been approved, they can be converted back to CAD files at any time. And then after the final adjustments and approvals in CAD, if that's necessary, we can then re-import them back into VR. Now, taking them back into CAD still will always have its place because it means that you can get down to the fine adjustments. But this is a very, very good way to broadly make these redesigns and then put them back into CAD and just dramatically reduce the amount of iterations. Thank you, Baptiste. Thank you, Nicholas. We're going to go back to the presentation now. Again, I'm going to ask you to put some questions in the questions tab based on what you've just seen. I see that there's some that are come up actually as we've been going, so that's great. Let's have a look at them. Okay. Michael has said, is it possible to walk the line in the sense that you highlight the entire pipe throughout the asset so you can easily follow it? The CAD usually is broken down into segments. That's a very good question, Michael. The advantage of this is that you can potentially model an entire oil platform or energy installation and actually place these right the way through. You can actually have the full run of the environment. So you can see how things, how disparate connections, modules, and arrays work together. Michael's also asked, how do we deal with wireless VR headsets and these visually large environments? Are you integrating remote rendering or reducing LOD, FOV? That's a good question as well. That's something which can be done in the right environment with currently tethered headsets, but there are other ways to do this. For instance, where there's even the potential for streaming to lower powered devices. But Hugo will give you the best answer at the moment. Edward has asked, could you overlap the AR, the augmented reality CAD and BIM files, which we were asking before? And we said yes. And he says, that's great news because it's taken the next step and can show the instruction manuals to allow for remote expert repairs from anywhere in the globe, reducing the cost of engineer support. Absolutely. Right. Now we're going to move on to your next poll. Okay, so the next poll is going to be, what applications can you see this being useful for in your industry? So I'm just going to add that to the polls section, and I'd love to see your answers to this. So these could be more collaborative work with global teams. It could be better involvement for stakeholder engagement across different disciplines. It could be assisting with modifications on site. It could be ability for multidiscipline engineering at the same time. So anything from electrical engineering to mechanical engineering, hell, even civil engineering. Things like planning for cost time estimates, planning for more complex designs, training and practical education, Safety planning could be an important one as well as ergonomics, and we will be coming back to both of these later. And anything maybe that we haven't mentioned, again, if you can add that into the chat, that would be great. So at the moment in the lead, we've got planning for cost time estimates, absolutely. Training and practical education seems to be in the lead, which is great because I have a training background and I would agree. And more collaborative work with global teams. You see, here's the thing. It doesn't matter where you are in the world, and it doesn't matter where your colleagues are in the world. You can be together in this environment, even if one of you is in Ghana, the other one is Oman, and the other one's in the North Sea. Doesn't matter. You're all in that same virtual reality training environment, working live together. And that's one of the main advantages here. So we also have planning for safety is coming out as a strong lead, because quite frankly, there's so many things that can go wrong in the real world environment. So if we can identify these and head them off with the right safety stakeholders and end users getting involved in this process, then we can remove the risks before they even happen. Fantastic. Thanks, guys. That's great interaction. Now, this next section is really quite interesting. This is where we're going to show you how you can select from custom libraries of components for your industry or for your application that you're going to be using it for. Now, bear in mind, we can provide these libraries of components, but in most cases, what we'll do is we'll take CAD models and actually import or create libraries, and you can do this as well within this tool, to create your own library of the components that you use in your industry. So you've effectively got a menu of components to draw from, and we'll show you how easy that is to do. Now, what's interesting about this is that these behave, they have the right physics and interactive physics, so they fit together as they would in the real world. So therefore, once constructed, we can move the completed assembly around as a single object. So you can put together 5 different components, make an assembly, and then move or clone that around, even adding it to your library if it's one that you're going to be using regularly. We'll also show, well, we're going to show pipe work here, which we've showed before, but it is important to note that we can also add and construct any other modular components, which could include electronics, it could include scaffolding, chassis components in the automotive world, it could even be surgical equipment. So I'm going to go back to you, Nicholas, and we'll go through it together. Now, from the collection picker, which we should be able to see here, there it is. We can work with accurately scaled components in context. And remember, all of these are one-to-one scale, so you're not going to get any issues of scale. Now, you get to see them in context, and you get to pick all the ones that are going to be most relevant to what you're doing, the task at hand, and the equipment that you might have available, or you would have available. Now, bear in mind that we can also keep track of this. So when it comes to actually making the orders for the components, you've got a record of everything that was used in that design. Now here, we can see whether or not we might have room to fit an assembly as planned, because there might not be room for another assembly because of other assemblies or other bits of your environment colliding with or constraining your environment, meaning that you can't fit that in. It's good to know this in advance so you don't end up designing an assembly which you can't actually get in at the end. Now, did you notice there that when these modules are put together, they flash green? They will only fit together in this virtual reality world if they would do so in real life. There we are. So then when they are going to fit together, they will flash green, and that shows that they have connected and bonded together, at which point it becomes a single unit. You can take it apart again and you can roll back through the system, but to all intents and purposes, this is now a solid unit, which would then have to be deconstructed, as we can see here. That means that you don't accidentally put together things which couldn't go together in real life. There we go. So once they've been successfully connected in the right way, male to female in the right direction, then they will flash green, as you can see there. So now you can see the completed assembly, which can be moved and repositioned as a single object. I'm just going to wait for Nicholas to actually finish off the assembly. Sorry, Nicholas, I was getting ahead of myself there. I'll let you finish off. Take your time. There we go, that's looking good. Okay, so now you can see that completed assembly. We could actually take that completed assembly and move that, reposition it, or even add it to our library again. There we are, which means if you're going to need this assembly in different parts of the oil platform, then you can place them in those different parts of the oil platform. You can also roll back to previous sections of the construction of the assembly if it was right up until module 3 or component 3, but then you kind of gone wrong a bit and you weren't able to fit in components 4 and 5. You can just roll back through the process until you get it right. Very good. Thank you, Nicholas. Good work. So again, we're going to come back to you guys. I'm going to see what questions you might have based on what you've just seen here. There we go. Dominic has asked, how many people can collaborate together in one environment at the same time? Well, it's up to 100 people. So not that you would likely ever need as many as 100 people in this kind of environment, but it does go to show that you're not going to be constrained by those numbers. Now, in terms of polls, we have another poll for you here. And this is, again, going to be very, very useful for us. And that is just to keep a kind of an update as to how useful or interesting you actually think this is going to be for you and your industry. So just publish that now. And it's effectively asking you to rate SkyReal Basics, or VR Basics, which is really just what we're talking about today. So I just want you to tell us whether this is something that is of interest to you, something that is not that particularly interesting or useful to you, or even if you have any issues that you don't understand. And if you don't understand any of these issues, then please do add them into the chat or the questions. And that's interesting. I'm going back to the previous poll where we were looking at what potential uses you might find for this tool within your industry. And Edward Murphy has said, automated purchasing and big data from sites consolidated for parts ordering or standardization. Good answer. Absolutely, that is true, because we can keep a record of the parts which have been which are required for these before they even get installed, before they're even ordered. We can see what's needed, what's going to work, and what's not going to work. It also reduces waste, because by seeing what's going to fit and what's going to work, we don't end up accidentally ordering parts which then become redundant, have to be returned, or maybe even can't be returned. It means that you order what you need when you need. Just going to go back to the polls and see how we're doing in your eyes. Oh, that's good news. We've got 3 are saying very interesting and 5 are saying interesting. Oh, and we've got 1 nothing special. Or you just wait. There's more to come. Good stuff, guys. Right, I'm going to move on to the next section now. We're doing well for time, by the way, so keep those questions coming. We'll have plenty of time for Q&A at the end here, okay? So keep them coming in. Now, what we're going to talk about now is the importance of the human element in engineering design. You see, anything that we create or edit in these systems ultimately has to be used by real people in real life, and we never want to lose sight of that. So we've created real scale, accurately posable mannequins to create a kind of a human context. That means that we can ensure that the system can be safely and easily accessible to real people on installation. So in our next VR demonstration, we're going to show how we can add and accurately position these within a scene for context, for functionality, for ergonomics, and also for safety benefits. So, Nicholas, back to you. Great. Now, here we're going to go inside what's known and infamous for being a particularly cramped and restrictive and electrically hazardous working environment, that of a wind turbine nacelle. There's a lot of training and engineering work required right at the moment, obviously in onshore and offshore wind power generation. But these nacelles, big as these turbines are, these nacelles are very small and very cramped, and there's a lot of risk in there. So here we can see the mechanical, electrical, and control components of the nacelle interior. See that? You see how little room there is to maneuver around all of these high-risk areas. Now, what we're going to do now is we're going to recreate a maintenance situation by placing a full-scale mannequin into the area. When I say full scale, obviously people vary in height, and that's something that we can adjust for. But in general, these will be within the parameters of real humans. Now here, we can actually place our mannequin's hand where that worker, where that maintenance worker would need to have his or her hands in order to complete the task. You can actually pose every bit of the body. But once we've got them in position, which we'll wait until Nicholas has got that in position. Excellent. So now that he's in position, we can display the areas of particular muscular stress, or MSDs, based on the International RULA, RULA, Ergonomic Safety Standards. And we haven't come up with this randomly. This is based on international standards for safe ergonomics. Now, do you see those yellow dots? So what we can see is that the posture that the worker is working in is relatively okay. Those stress areas are not hugely stressed. But we're going to bring in another mannequin here, as you can see, and we're going to put this worker in a slightly more awkward position. Now, bear in mind, some of these maintenance tasks can take a long time to perform. So that person is going to be in this position for quite a long time. Come on, Nicholas, really put him under pressure. There we go. Now, do you see that? How in certain positions, these MSD points are going red. Now, that is an indication that the worker is having to operate, or the position that the worker is having to operate in is putting unsustainable stress on their body. By making minor modifications to the platform that they're standing on, or even by placing real-world posters, like safety posters showing recommended working postures, into the real-world environment, we can actually quickly resolve these issues before they become a problem. Now, that only reduces, obviously, risk of injury and risk of claims against health and safety. It reduces all of the waste of people being off work, making claims against you before they even potentially happen. So we can adjust things like tools, platform heights, and obviously the awareness of the correct posture to work in, or the incorrect postures to avoid. Now, what we're going to do is we're going to highlight potentially hazardous areas. We're going to start by highlighting potentially live electrical components. So do you see here, we can actually change the color of those components and have color coding so that they know before they go in, the maintenance workers, this bit's live, stay away from this, or within training to know what to stay away from. These icons that Nicholas is putting in right now will highlight what the hazard is, so accurately reflecting the type of hazard. In this case, it's an electrical hazard. There we are. And through color coding, we can highlight just what kind of electrical hazard that is. Now, that was obviously an electrical hazard. Let's have a look at falls risk. Nicholas, can you find us an area where somebody might fall if they weren't careful? There we go. It is a long way down here, and we want to highlight that that's a falls risk. We want to make sure that people are aware that while they're busy and occupied with other things, they don't accidentally back themselves down onto somewhere where they could end up falling to the ground. Now, while Nicholas is doing this, I want you to notice that there's a large geared system on the ground there. So not only is there a falls risk there, there's a crushing risk, a mechanical crushing risk. Now, normally these things would be locked in place while maintenance was occurring, but failures do occur. So we need to make sure that people keep their hands clear of that area. Nicholas, could you show us the cones that we can use to cone off areas? Cones and barriers are a particularly good way to highlight ground risks and falling risks. You'll see in that picker that we also have highlighting where fire extinguishers might be and highlighting where other safety features might be. Very good. So that we can make sure that these are in the right place and the right fire extinguisher is in the right place for dealing with, for instance, chemical fires, oil fires, and electrical fires. We can choose between those as well. Remember, any model that you want can be uploaded and any scenario can be catered for. It's a very flexible system. Thank you, Nicholas. I think that's covered a lot. Okay, so again, I want to come back to any questions that you might have about the ergonomic and safety capabilities of the mannequins and add them to the questions section in the right there. There we go. We've got a lot coming in. So that's brilliant. And then I'm going to bring up our next poll while we're waiting. Now, this is our final poll. So we wanted to take the opportunity to ask you what other industries you would maybe like to see the SkyReal presentations on the system for. So I'll just bring that up now. So the other industries that we were looking at are things like agriculture, subsea, aviation, working at heights, construction, power stations, and education and training. Pretty much all of these that we have experience in working in, and we're always interested in other industries that we might not have. So although it doesn't say here none of the above, if there are any that we haven't covered here, I'd like you to add them into the chat. What I'm also going to do while we're at it is, let me just see, I'm going to add the next poll here, which is what topics would you like to see presented in the next webinar? That could be the capabilities that this system has, which could include data preparation from CAD. It could be remote collaboration that we could focus in on. It could be going from design and virtual reality and back to CAD. It could be advanced customization with the user experience. XR, an XR center, our XR center, so you can see that how that works. And cave and Powerwall. Very good. We've already got answers coming in. That's brilliant. I'll give you a wee second to add some more of these in. Now, at the moment, we've got some winners in terms of you'd like to see some stuff specifically in education and training. Not a problem. We actually have some amazing education and training applications we're working on right now over in Oman. Power stations, good, good. That's something that we're strong on. Construction, very good. Things like working at heights and working in hazardous environments in construction is a brilliant application for this tool. Aviation is good. I mean, this system was based around aviation, so we've got a wealth of information on there. And agriculture. Did you know that agriculture is the single most hazardous area to work in out of all of them? That was a surprise to me. But when you think about it, you're working at heights, you're working with animals, you're working with electrical risks, crushing risks, all sorts of different mechanical and electrical equipment. There's all sorts of risks and hazards there. So that's a good one, agriculture. And in terms of your main interest for our follow-up presentations, you're saying data preparation is good. Remote collaboration is a major one. Design in VR and back to CAD, you like to see a bit more of. And a lot of people wanting to see the XR Center. Fantastic. Okay, great work, guys. I'm going to move on to the next section and we're going to get to our questions. Okay, so we're going to go over some of your key questions with SkyReal's developer and founder, Hugo Falgron, who was answering your questions in the chat there. So Hugo, I'm going to bring you up so that you can chat to everybody now, okay?
Yep, thank you, David. So I think we've been through all of them, I mean, just by text, but I think there was some question about Edward has many good ideas and questions. So I think there was a question about centralized database and how about getting all these components linked to AR and also linked to ERP, which is a pretty good idea to get more or less the list of all the parts that you can, let's say, drop into the models and you would like to get out of this experience, the list of all the components you have more or less identified as a. So I think it's really a very good idea that we did yet, but I think it's something we could really think about because we are building API and really for focusing a lot about what we export out of this experience. I mean, we are not doing VR just for the fun, but of course it's to generate added values for the engineers and so on. So of course, if we can, on top of that, I mean, once you have, let's say, plug all your pipe modules and so on, if you can generate out of that a list of components that you can send to anything, I think it's pretty good idea. And it was a question about also this centralized database of files in CAD, which is, of course, as I answer, it's something we are already working on. This is what we call XR Center. And it's about how to share all this experience model as a collaborative inside an organization, or let's say on an external approach, also with an extended company. It's not meant to be a free CAD model database. It's like a BIM software where all the suppliers share their models and so on. Maybe it would be a next generation of that, but I'm not sure we can do that right now, but we can think about how to exchange between companies. I mean, if there is suppliers of, let's say, pipe modules and some suppliers of, I don't know, engines of pump or whatever, maybe how we can build up on that. So, I think it's a really good point on this. So there's a question about the SkyReal user sell point. So there is many solutions here, and so that's right. So the selling point. So the unique selling point is really about getting the VR, available for any engineers working with CAD models and so on, and which are not, let's say, computer science or any VR expert, but something which is really clever, easy to use, and doesn't request any training and I would say expertise. Okay, so the really difference with what exists on the market is the quality of the user interface and the robustness of the solution, and something that should be, let's say, available every day with the quality of the rendering and the quality of the software in terms of, the software runs on any kind, and you don't need to, let's say, to know that there is a specific way, you need a 5-day training to use it and so on. It's really something that should be, everyone can buy a HMD and a computer and run this, and it should be very easy to collaborate. And I think there are not so much on the market solution that helps to join, let's say, a team of 20 people for a meeting just for 5 minutes. You can put that on your chief engineers, and this is really what we believe we are unique, and that make a difference with competitive offers. Right?
Great stuff. Thank you, Hugo. I'll just take us to the closing sections then. Now, based on the polls that we've seen, we're seeing really strong interest in doing follow-ups with design in VR and back to CAD, things like remote collaboration, the XR Center, and the data preparation from CAD. We're also seeing strong interest from the education and training perspective. I think any given industry is going to have an interest in using this for education and training, so I can see why that would be so popular. But also a lot of interest in construction, as well as aviation, agriculture, and power stations, which is great. So bear in mind, though, that we're not going to be restricted just to that. We will come back to you with all the questions and answers and any follow-up demonstrations that you would like us to deliver to you and your colleagues within your company. If you have any interest in any of the other functions and features that we haven't had time to mention, just put them in the comments and we'll come back to you with them. Now, remember that the SkyReal system can also offer things like, and I'll bring them up on the screen, movable electronic and pneumatic rigs, which we call kinematics, education and training applications, obviously, raw data outputs and visualizations, animated mobile visualizations so you can actually see things moving and how they would move in the real world, and physics modeling capabilities, which can be really, really useful when it comes to structural integrity and so forth as much as anything. So I'd like to thank you guys for your time and your questions today. Based on the contact details that you've given us, we're going to send you a recording of this event and a summary of all of the questions and answers that we haven't had time to cover today, although I think we've covered most of them. You'll also be given the opportunity for a custom demonstration for you and your colleagues in your company according to your own industry needs or specific interests, which you can outline to us. In the meantime, don't hesitate to get in touch using the contact details and the additional information on the screen here for any other questions that you might have. So I'd just like to thank you again on behalf of Hugo, Nicholas, Benedict, and myself for your time. And I look forward to speaking to you again about this system very soon.
Thank you so much, David.